Our next topic is solving absolute value equations. Now, remember what the absolute value means. It means the distance from 0. Now, we often say that the absolute value makes the value inside the bars positive. It's just a shortcut way of thinking about it. For example, the absolute value of 15, well, how far is 15 away from 0? Well, 15 units. The absolute value of negative 15, well, if on the number line, how far is negative 15 away from 0? Well, 15, because distance is always positive. Again, the fast way of thinking about that is just whatever's inside the bars, when it comes outside the bars, it just becomes positive if it isn't already positive. Okay, so what I want you to do is solve these in your head. So I want you to think of what number, knowing what absolute value means, what number do you think can go in here where the absolute value of some number equals 3? Now usually when I do this in a face-to-face class, we have x is equal to 3, and a lot of students will shout that out, oh, 3! Okay, well 3 does work, and the reason 3 works is because the absolute value of 3, that's 3, not 13, does equal 3. Now, can anyone think of another solution? And then maybe one or two students might think of this one. Not everyone, but x is equal to negative 3 also works because the absolute value of negative 3 does equal 3. So when I'm trying to solve the absolute value equals 3, I get two solutions. I either can have positive 3 because the absolute value of positive 3 is 3, or negative 3 because the absolute value of negative 3 is 3. But let's look at the next problem. I have the absolute value of x is equal to negative 3. So solve this one in your head. What value can you think of that when you plug it in for x, that the absolute value of that number is negative 3? And then sometimes people might say, well, what about 3? If I take the absolute value of 3, is that ever going to be negative 3? Well, no, it's not. So 3 doesn't work. And then someone might say, oh, negative 3, does negative 3 work? Is the absolute value of negative 3 ever going to be equal to negative 3? No, that doesn't work either. So the solution here turns out to be no solution. And the reason it's no solution is because when you take the absolute value of anything, didn't we just say it makes it positive? So whatever we plug in for inside the bars, it needs to come out and be positive, not negative. So this one has no solution. So notice that the sign on the value determines if the equation has any solutions. So here's your steps. The first thing I want you to do is isolate the absolute value bars in the equation. So I want it to be whatever the expression is inside the bars. It could be anything you want, but the bars have to be all by themselves equals some letter C. Now, if the C is non-negative, which really just means it's positive or 0. Non-negative means positive or 0. Then what I want you to do is split the equations into two equations without the absolute value bars. And they're going to look like this. Either the expression inside the bars equals C, so whatever the expression is could be equal to C, and the absolute value of C is equal to C, or the expression inside the bars could be equal to negative C, because if the expression equals negative C, when you take the absolute value of negative C, it turns out to be positive C. Lastly, you'll need to solve. So these are the steps to take if it's non-negative. Now, if C happens to be negative, then the answer is simply no solution. There isn't any case where if you take the absolute value of it, once the absolute value bars are isolated, that you're going to get a negative number. Because the absolute value of any expression can never be equal to a negative number. So let's practice these. Okay, step 1. Are these absolute value bars isolated? Well, in this problem, they already are isolated. The second step is to determine is this 2 positive or 0? Well, the 2 is positive or 0, so that the answer is yes, which means I can keep going. Okay, so because I can keep going, I'm going to split this up into two equations. X is equal to positive 2 or x is equal to negative 2. I might be able to continue solving these, but in this case they're already solved. So my answer is just 2 and negative 2. I put my solution inside these braces because those braces indicate that the things inside them are the solutions to the equation. That's just set notation. Let's try this again. Is the absolute value bars isolated? Yes, they are, so that step's already done. Then I ask myself, is negative 3 positive or 0? Well, no, negative 3 is neither positive nor 0. So because the answer is no here, I cannot keep going. So my answer is simply no solution. On this next problem, are my bars isolated all by themselves? Sure they are. Now there's a whole lot more inside the absolute value bars. There's an expression here, but that's okay. The bars are isolated. Then I ask myself, is 11 positive or 0? And the answer is yes, 11 is positive. So I can break this up into two equations. 2x minus 3 is equal to 11, or 2x minus 3 is equal to negative 11. At this point, I'm going to have to solve each of the equations independently. So I have x is equal to 7, or x is equal to negative 4. So those answers will go inside the braces. Okay, next problem. Are my absolute value bars isolated? Is there anything else on that side of the equation other than just the bars? Well, no, not yet. So this 7 plus 7 and the multiply by 4 have to be removed from the side with the bars in order for it to be isolated. My first step is to subtract 7 from both sides. And then I'm going to divide both sides by the coefficient so that my bars, x minus 2, the absolute value, can be all by themselves. So that took a couple of steps just to get step 1 done, isolate the bars. The next thing I ask myself is this negative 1 positive or 0? Well, negative 1 is not positive, nor is it 0. So because the answer is no, I actually like these problems a little bit better because when it's no, the answer is just no solution and I don't have to do any more work. Yay. Okay, next problem. I have the absolute value bars right here. Are they all by themselves? No, so I have to spend a little bit of time. I'm going to subtract the 2 from both sides first. Next, I'm going to get rid of the 7 in front of the bars by dividing both sides by 7, which gets me the absolute value of x is equal to 2. Now that the bars are by themselves, I ask myself, is 2 positive or 0? And the answer there is yes. So because 2 is positive, I can continue by breaking these up. I have 3x is equal to 2, or I've got 3x is equal to negative 2 using our steps from above. Then I'm going to solve each of these, and I get two solutions. X is equal to 2/3, or x is equal to negative 2/3. So my solution set is 2/3 and negative 2/3. You'd only ever use solution set for solved problems, by the way. So there's my solution. My last problem, I've got my bars not yet isolated. So I'm going to first subtract 7 on both sides, which gets me 2 times the absolute value is equal to 0. And that accidentally goes to 0. I didn't try for that to happen, it just did. Then I take both sides and divide it by 2, so I get 3x minus 1 is equal to 0. Now that the absolute values are equal to 0 or isolated, I have to ask myself, is this 0, this number 0, is that positive or 0? And the answer is yes. So because it's positive or 0, then I'm allowed to continue to solve the problem by setting the expression equal to positive 0 and the expression equals to negative 0. Now this is one of those little bit weird cases because 0 is neither positive nor negative. So when I end up solving these, I'm going to get the same solution. So I have x is equal to 1/3. On the other side, negative 0 plus 1 is still 1. So because I got both answers to be the same in my solution set, I just have to put 1. And that's my answer.